All right, we're back and better than ever, talking about section 4.4 today, solving ax squared plus bx plus c equals 0 by factoring. And some of you will notice that that looks just like the last stuff we did. The only difference between this and the last stuff we did, that a will be some number other than 1, which makes it a little bit more complex. So you're going to factor something like y equals 2x squared plus 9x plus 7. And if you remember before, we would ask the question, well, when I what multiplies together to get 7 and adds up to get 9? Well, in this situation, you can't do that anymore. And let me kind of demonstrate why over here. If you have something like 3x plus 1 and x minus 4, when you do the first, you get that 3x squared. That makes sense. When you do the last, you get the negative 4. That's fine. But when you do the insides and the outsides you get plus 1x. The outsides you get minus 12x. And you'll see where that kind of comes into play there. 3x squared minus 11x minus 4. You'll see where having that leading coefficient changes things just a little bit for what we are doing here. So where k and l in this situation here, where k and l have to be factors, see k and l here, you have to be factors of 2 because they multiply that first, got to multiply out to be 2. M and n have to be factors of 7 because 7's right here. And because m times n is greater than 0, it's positive 7, m and n have to be the same sign. Either it's a positive times a positive to get positive 7, or it's a negative times a negative to get positive 7. So m and n must both be positive because the coefficient of x is a positive 9. Okay, if that was negative right here, then they would both be negative. All right. So the k and l are obvious. They're 2 and 1. The multiples of 7, they've made those pretty easy. That's either 1 and 7 or 7 and 1. So my choices are 2x plus 1 and x plus 7, or 2x plus 7 and x plus 1. One of them, when I FOIL them back together, will equal this. One of them will not. So the outsides and the insides won't matter. The first and the last won't matter. The outsides and the insides will matter. Both of them will end up with 2x squareds. Both of them will both end up with a 7. And they'll have a plus and a plus on both of them. The only difference is when I do the insides on this one, I get 1x. When I do the outsides, I get 14x. 1x plus 14x. 1 plus 14 is 15, not 9, so that's probably not the right answer. When I do the outsides here, I get 2x. When I do the insides, I get 7x. 7 plus 2 is 9. That looks like the right answer. So it's 2x plus 7 and x plus 1. And so those two things go together. When I look at another one, it's a little bit more complicated when I look at example 2 down here. In example 2, I have 3x squared. I have 3x squared minus x minus 2. Well, because k and l are factors of 3, and m and n are factors of negative 2, well, not because, but just that's the way it is. And because m and n, m times n, you see, end up being less than 0, m and n have the opposite signs. That means one of them is positive and one of them is negative. So all my possibilities are 3 and 1 for the front term. That's easy. Always 3 and 1. But for the second term, negative 2, it could be negative 1 and 2, 2 and negative 1, 1 and negative 2, or negative 2 and positive 1. A lot of choices there. So we're going to have 3x, 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 3x. We're going to have 1x, or just x, right? But we could have minus 1 and plus 2, plus 2 and minus 1, plus 1 and minus 2, and minus 2 and plus 1. You see how that correlates with these numbers right here. So those all kind of go together. All my possibilities. Remember, I set them up so that every one of them will have 3x squared in the beginning. First, when I multiply 3x times x, 3x times x, 3x times x, 3x times x, 3x squared. My lasts will all be negative 2, every one of them. It's the middle that I'm worried about, the outsides and the insides. On this one, I got the outsides plus 6x, insides minus x. Well, 6 minus 1 is 5. Not going to work out. I'm looking for negative 1 here. Outsides, negative 3. Insides, 2. Negative 3x plus 2x. Oh, there it is. I don't have to go any further. Negative 3 plus 2 is negative 1. I know my answer is 3x plus 2 and x minus 1. All right. Let's go on to the next page. You guys go ahead on this next page here and just see how you're doing on that. Go ahead and do 1 and 2. I'm going to give you give yourself like 3 or 4 minutes to just work through it and see how you do, and we'll come back. So go ahead and pause the tape. We'll come back and take a look. All right. Now when we look at this, your leading coefficient is 3, so that's 3 and 1. So I know I have a 3x and an x. I have a negative 20. A lot of possibilities for negative 20. It could be negative 5 and 4. It could be 4 and negative 5. Well, remember, one of them's 3 and one of them's 1, so you actually can flip those as well. You could have negative 4 and positive 5. You could have 5 and negative 4. So those are all different possibilities for 20, on top of 2 and negative 10, negative 2 and positive 10, 10 and 2, negative 10, 10 and negative 2, negative 10 and positive 2, plus 1 and 20, 1 and negative 20, negative 1 and positive 20, 20 and negative 1, and negative 20 and 1. All of those possibilities for my answer here. I hope all of you found that it was minus 3x minus 5 and x plus 4 when you went through the steps. And on this one over here, I hope you got 5x minus 3 and x minus 2. I think if you check those, you'll find that they work, but you have to work through all of these to get to that point. When we factor something like this, you'll notice what you have right away is that difference of squares that we talked about last time. That's 4x squared and 6 squared. And if I have a difference of squares, it's 4x plus 6, 4x minus 6. All right. Take a look at this next one. Now this next one's pretty tricky, and I don't know how many people are seeing this, but it's 3y squared, and then it's of that perfect square trinomial. If you look in your notes, you'll see that perfect square trinomial. 3y, and then 2 times 3y times 7, because on the end you got that 7 squared. So you'll see that that's 7 squared, and that's 3y squared, and then those two are both in the middle. And that perfect square trinomial is 3y plus 7. And the other perfect square trinomial, which I think this is a pretty difficult concept, is you got 5t squared here, you got 11 squared here, and then when I multiply those things together, the 5t and the 11, that's how I got 110. So that turns into 5t minus 11 squared. Go ahead and take a minute and work on this next checkpoint. I'll give you just a couple of minutes to work on that. Alright, welcome back. I hope you guys found 4y minus 5 quantity squared in this one, 2x plus 9, 2x minus 9. If you missed the first one, don't worry about it. On the second one, you do need to notice that that's 2x squared minus 9 squared. Difference of two perfect squares. That's what we're looking for there. Take a look at these next examples that we're going to go over really briefly here. 4x squared minus 4. Well, notice that 4 is in both of them, so I'm going to divide 4 out of there, and I'm going to get 4 times x squared minus 1. Well, x squared minus 1 is x squared minus 1 squared. That's a perfect square, so I end up with 4 times x minus 1, x plus 1. Pretty tricky stuff there. This one, again, they both have a same factor. They both have a negative 3 and a y. So I end up with a y and a 6. A y plus 6 in there. Pretty tough. This one, all divisible by 2. So, and actually negative 2, two of them are negative, so I'm going to make it a negative 2. 2m squared plus 5m minus 12. And then, that probably the toughest one. Then on top of that, you can extrapolate a little bit more and say, look, 2m minus 3 and m plus 4. And that was looking at this one like we looked at those first ones in the paper. Okay. This one, 5 goes into all of them. All right, so I take the 5 out, but once I do that, I find that nothing else I can do with that. There's no numbers that when I multiply together to get 8 add up to 5. So that one's done. Okay. Take just a moment and go ahead and do 5 and 6 and just try them. See, those are tough problems. Do your best on them. I'll give you a couple minutes, pause, and come back. All right, welcome back. I hope you saw for yourself on that one that the number 4 goes into both of these right away. So I have 4 times 9x squared minus 4, and that's a perfect difference of perfect squares. 4 times the quantity 3x plus 2, 3x minus 2. Pretty tough one. And that next one, not expecting a lot of people getting this one. Really pretty tough problem. But if you did, give yourself a pat on the back. It's a pretty good one. Let's take a look at this last one. Solve this quadratic equation using factoring. That's what we've been building up to. That's what we're trying to get to. So we have 2x squared minus x minus 21. Numbers that will work in this. Well, one of them is going to be 2x, so I'll make the first one 2x. The other one's going to be x. When I multiply them together, I get a negative. So one of them is going to be positive, one of them is going to be negative. So I could have negative 1, positive 21, or 1 and negative 21. I could have 21 and negative 1, or negative 21 and 1. I could have 3 and 7, or 3 and negative 7, or negative 3 and 7. I could have negative 7 and 3, or 7 and 3. A lot of choices here, but I need the answer in the middle to be a negative 1. I hope you see that negative 1 there. So the numbers have to be fairly close together. And so I think the 1s and the 21s are too far apart to get me there. I'm going to look at the 3s and the 7s. And I know that 2 times 3 is 6, and 6 is 1 away from 7. So if I put my 3 over here, I'm going to get the outsides will give me 6. The insides will give me 7. 1 times 7. And I want it to be negative 1, so I'm going to make this 7 here, negative 7 plus 6. And if you multiply that out, you'll see that just a little bit better. So 2x minus 7 equals 0, or x plus 3 equals 0. And if I add 7, divide by 2, I get 3.5, or 7 halves. If I subtract 3, I get negative 3, and there's my answer. So that's, one way to do that. Here's something else. This is a big picture item right here. We're going to subtract 6r, and we're going to get 4r squared minus 24r, and I'm also going to add 12 plus 36. So I move those over there, and I get 0. 4 goes in all of it. 4 gives me r squared minus 6r plus 9. If I divided everything by 4, that 4's go away, and 0 divided by 4 is still 0. Right here, I can end up with r minus 3, r minus 3, or r minus 3 quantity squared. So that means r minus 3 equals 0. R must be 3. Go ahead and try these on your own. This is negative 5 and 3, and this is negative 4. Thank you, and I'll see you next time.